ready to start if you want to start recording. Thank you very much. Welcome everybody to our Sustainable Solutions lecture series. It's really a pleasure to welcome everybody and to welcome our wonderful speakers from the Nature Conservancy. Before starting and introducing our speakers, I would just like to mention a few words about the Sustainable Solution lecture series. This is a system-wide collaboration, a UMass system-wide collaboration. The lecture series is hosted by the School of Earth and Sustainability. And before I start telling you a little bit more about the series and about today's event in particular, I would like to leave the floor to Rob De Conto, the director of the School of Earth and Sustainability, for a few opening remarks. Thank you very much, Rob.
Thanks, Marta, and welcome everyone. I'm thrilled about today's event, and we're so happy to be able to support you, Marta, and the lecture series. And today's lineup is just tremendous. So the School of Earth and Sustainability at UMass Amherst, we're basically a pan-campus, ultra interdisciplinary network of students, faculty, scientists, innovators. So most of what we do is connect programs, experts, regional partners with the notion of advancing transdisciplinary research, accessible education, green workforce development, and getting our students out into community, so real community engagement. So, ultimately the intent is to drive sustainability solutions. So we're obviously really aligned with today's topic. We are focusing on things that are really well aligned with TNC and what we'll be talking about today: climate hazards statewide, coastal resilience in particular, food systems, sustainable agriculture, climate tech, nature-based solutions, and of course, supporting green and blue economic development. So in addition, I just want to say that in addition to the school at UMass Amherst, we house at UMass Amherst, and we're proud partners with groups like the Energy Transition Institute. We have graduate training programs in the energy transition. We have the Center for Agriculture, Food, and the Environment, which is part of our extension mission as a land-grant institution that includes the Clean Energy Extension group of folks. We have, what else would be really relevant? The Academic Center for Reliability and Resilience, AERO. And the Northeast Climate Adaptation Science Center is also housed at UMass Amherst, representing most of the U.S. Northeast. The other thing that we've been doing in recent years, and this is again really germane to today, is we're working hard to strengthen our regional partnerships, beginning in the Commonwealth, but moving beyond the borders of Massachusetts. This has included networking and bringing together and collaborating the UMass system of campuses and all of its wonderful coastal research facilities. That collaboration across the UMass system, this lecture series is a great example of just that collaboration itself. We're trying to make and build better and more powerful and meaningful relationships with communities, Massachusetts tribes. We have external academic and private institutions that partner with us now, including industry, basically from Rhode Island to the Canadian border along our coast. Collectively, I'd like to say that we're proud to say that we've been impactful in supporting state agencies and initiatives that include energy and environmental affairs, the coastal zone management, the Resilient Mass and Resilient Coast initiatives. March has been working very closely with Massachusetts Municipality Agency, the MVP program, and of course, many of us have been working with the Clean Energy Center in particular. So given all of this alignment with TNC, today's topic, we're absolutely thrilled in supporting this event. I'm looking forward to it. Thank you all for being here. And with that, Marta, I'll turn it back to you.
Thank you so much, Rob. I'm going to share screen again just to introduce our participants. And I encourage our assistants, Marina and maybe Brita, to share the link to the Sustainable Solution lectures in the chat. The idea of the Sustainable Solution lectures is really to develop new conversation, or to strengthen conversations about sustainable solutions. And this involves many partners and the support of many collaborators. And I want just to spend a moment to recognize our partners in the UMass system. As we said, these sustainable solution lectures are supported by the School of Earth and Sustainability, but also with the support of the School of Public Policy, the School for the Environment at UMass Boston, the Sustainable Solutions Lab at UMass Boston, the Reefs Institute at UMass Lowell, UMass Dartmouth, the UMass Chan Medical School, the Stone Living Lab. We might have Catherine Daffern in the audience today, its director. The Naturance Project, which is a consortium of European universities, funded by the European Union. And I'm very grateful that this year we also able to work in the development of these lectures with the Nature Conservancy, the Massachusetts Municipal Vulnerability Preparedness Program, and the Executive Office of Energy and Environmental Affairs, and always the Massachusetts Municipal Association, which has been a partner with us for several years now. As I said, the goal of these lectures is to create a cross-sectoral forum to strengthen collaborations and develop new ones. And we welcome the actors from private sector, public sector, and academia, and international organizations and nonprofit organizations. So I'm really excited for today's event. We will focus on coastal resilience, offshore wind, and nature-positive solutions. We will look at the possible convergence between offshore wind development and habitat conservation. I'm very excited to welcome our speakers. Boze Hancock, I'm going to say a few words about each one of our speakers. Boze Hancock is the Senior Marine Restoration Scientist for the Nature Conservancy's Massachusetts chapter. Boze comes from a fisheries research background in Western Australia. He has more than 20 years of experience based in the US, developing restoration of the critical coastal habitats around the US, as well as in China, Hong Kong, Australia, and Europe. In 2020, Boze initiated the SOAR, Supporting Oyster Aquaculture Restoration Program in the US. This program involves oyster growers in conservation. Boze is also actively developing techniques to scale restoration through integrating oyster reef restoration into the construction of offshore wind infrastructure in Europe. I'm really excited to hear more about these projects. We also welcome Trisha Gedele, I hope I'm pronouncing your name correctly, Ocean Program Director for the Nature Conservancy in Massachusetts. Trisha is an attorney, an environmental leader. She joined the Nature Conservancy as the first Atlantic Coast offshore wind policy manager in 2021. She coordinates and leads TNC's offshore wind energy efforts from Maine to North Carolina. Before joining TNC, Trisha served as the chief of the Environment and Energy Unit of the Rhode Island Attorney General's Office. And she also served in the past as vice president and Rhode Island director of the Conservation Law Foundation. In that capacity, she worked with federal and state agencies in developing the first the Rhode Island Ocean Special Area Management Plan, which is the first federally approved ocean plan for offshore wind in the United States. So really, I think we're going to have really exciting discussions with Trisha. The program today will include a video from Chris Gillies, who's based in Australia. He's currently managing the Nature Conservancy's Australian Marine Branch, where he's leading the Great Southern Seascape Program, which is a program that helps to protect and restore healthy ecosystems, marine ecosystems from Western Australia to New South Wales. And previously, he was the director of science and at Earthwatch Australia. And last but not least, during our discussion, we will welcome also Chris McGuire, who's the Ocean Program Director for the Nature Conservancy in Massachusetts. He's also the lead for the Northeast US. He's focused on implementing collaborative solutions to pressing fisheries and conservation challenges across the Northeast. Chris chairs both the New England Fisheries Management Council's Habitat Advisory Panel and the Selvagen Bank Sanctuary Advisory Council. Here in Massachusetts, he is appointed to the Marine Fisheries Advisory Commission and the Ocean Advisory Commission. We're going to have a fantastic conversation and discussion today. I'm going to stop sharing my screen and I'm going to leave the floor to Boze Hancock. Thank you very much for being here with us.
Thank you very much, Marta, for the introduction, and I am delighted to be here and honoured to be invited. So I will share a screen and get a few slides going. So thanks very much for attending, and I will just give a quick description of the run of show as I have prepared it for today. Apologies to anybody in the audience that is completely au fait with marine habitat restoration. I'll just give a very brief stage setting for those who aren't, and go into why oysters, and describe the situation around native oysters in Europe. I'll then hand over to Trish Yadley to describe some of the policy drivers that are helping us implement before I do a deeper dive into the in-water work that's going on the proof of concept level in Europe. And as Marta's mentioned, hand over to Dr. Chris Gillies from Australia in a recorded presentation. So what does marine habitat restoration look like? Oopsie, I'm not advancing. Here we go. It's essentially exactly the same as in the terrestrial biome. We are focused on the biogenic habitats, the growing habitats that create structure, but rather than forests, grasslands, peatlands, we are working on the critical coastal ecosystems, and that coastal word is important. The vegetated habitats include the salt marsh, seagrass, mangroves, giant kelps, and the reef systems. And really the only thing to say here is that these coral and shellfish reefs are ecological equivalents. The corals dominate in the tropics. As we head towards the higher latitudes on either side of the equator, the shellfish should take over that reef forming function. Unfortunately for the shellfish, most of them are edible, so those reefs no longer exist, which is kind of the topic of today's presentation. I won't dive into the ecosystem services in any great depth, but the reason for focusing on shellfish reef is the services that they provide. The point that I would make is that we can contrast an artificial reef, picture a pile of rocks in the ocean, and a pile of rocks and an oyster reef do share a number of services. They both provide sheltering structure for a large section of biodiversity. There's a surface for recruitment. They provide feeding grounds. The thing that separates the oyster reefs from an artificial reef is really the filtration. These are filtering engines. It's a good-sized oyster in warm water that filters 50 gallons a day, but even at 20 gallons a day for a legal-sized oyster, when there are millions of them, that's a large volume of water being filtered. And the trick that oysters have is that they take out all of the particles from the water, down to about 4 to 5 microns. They ingest what they want, but the rest of that is attached to a mucus thread, spat out, it's heavy and sinks into the reef structure. So that contains all of the biodeposits, all of that material that was inaccessible in the water column is being actively fed into the reef. So not surprisingly, the biodiversity and particularly the biomass goes crazy. Now, these are the only data I will present, so don't worry too much. And you don't have to look at the numbers, just the order of magnitude. That table on the top left is non-restored versus restored, and abundance, number of animals with dry tissue weight as biomass. And the animals have been grouped into species groups there. So just scanning those numbers, you can see that we've got a 1 to 3 order of magnitude increase in both abundance and particularly biomass. And that's a really powerful driver in the marine environment. Excuse me. The graph on the bottom right is actually just a subset of that biodiversity. That's the fish production, fish and large crustaceans. The way to read that is the y-axis is most easily interpreted as tons per hectare. So we're looking at the mid-Atlantic at about 3 tons per hectare per year of additional fish in the system because of restored oyster reef. This is actually comes from what I believe is still the only method we have developed in the fisheries community to quantify additional fish produced by a habitat rather than attracted in, fish that already exist that are attracted in. And it's based on the differential survival of the 0+ year class, those juveniles. So 3 tons per hectare per year of new fish in the mid-Atlantic. We don't have those measures yet from Europe, but we expect it to be pretty similar. So with that kind of production, the return on investment for reef restoration is actually pretty interesting. We have some good return on investment data from Australia, but by far the best comes from the Chesapeake Bay. The 10 tributaries restoration program that finished in December last year. The first of those tributaries was Harris Creek from the little Choptank complex in Maryland. And that was quite the exercise. They've all been pretty big, those tributary restorations. Harris Creek was 142 hectares, about 350 acres, huge amount of substrate to create the base of the oyster reef, 2.5 billion spat on shell and $53 million spent doing it. So these are expensive exercises, but they were monitoring every 3 years, and following the first 3-year monitoring, there was an economic assessment done. And I spoke about fish production. You can see there 160% increase in blue crab production from that reef. The extra blue crabs produced from that reef were worth $11 million a year just in blue crabs. If we add in the other economic benefits from that work, we get to about $23 million a year in the return on investment. And that's approaching a 50% return on investment. So this natural infrastructure really is a valuable commodity. The other point I'd make is that we've had quite a bit of practice. We have been restoring oyster reef in America for over 2 decades. And I've been lucky enough that part of my portfolio has been expanding that work out from America to other regions. And myself, I've worked in 4 regions, 7 countries, including the US, Europe, China, Hong Kong, Australia, New Zealand. And I'm certainly not the only one doing it. So there is a wealth of experience around the globe for oyster reef restoration. And that includes in Europe. The Native Oyster Restoration Alliance, NORA, was started in 2017 with the intention of keeping our arms around a growing portfolio of projects in Europe. It's a volunteer group, and the working groups, it's divided down into working groups that are actually producing the outputs from NORA. And one of those working groups is a historical ecology working group who have done a fantastic job dredging back through all sorts of data sources, certainly not stuff that's available online from Google search, but going back into the history to put together the history of the habitat that are created, the reefs created by oysters. It was led by Ruth Thurston from Exeter University. And this shows the distribution of the native oyster in Europe, from the Black Sea across the Adriatic, Mediterranean, Atlantic coast, and in the North Sea region. So if we focus in on the North Sea region, a number of the records that the Historical Ecology Working Group found gave a high confidence of both area of reef and location. was under a quarter. I think it was about 23% of the records gave that kind of detail. And just from those records, we can document 1.75 million hectares of reef that's been lost from the North Sea region. So there's no question that oyster reef was a dominant structuring habitat in the area. And once you've got that kind of historical ecology, it was a pretty easy task to apply the IUCN ecosystem red listing criteria. And not surprisingly, it comes out as completely collapsed. There's very little of that reef left. So if we contrast that chart, which is on the right of this screen, with the area of offshore wind lease, both existing and planned, I mean, you don't even need to squint at those two charts to understand that there is a high degree of overlap between where oyster reef once was and where offshore wind is being installed. So that creates the kind of potential for a synergy that I will describe. But that will be after Trish Yardley introduces us to the policy environment. So Trish, over to you.
Great, thanks, Boze. And I'm just going to zoom out a little bit to talk about why we're looking at offshore wind and as a delivery mechanism for some of the restoration. So we are experiencing a serious but also a measurable global decline of biodiversity. This decline threatens 1 million species and impacts billions of people. This graph from the World Economic Forum shows that between 1970 and 2018, there has been an average 69% drop in the abundance of monitored populations, representing 5,200 species across the globe. So there are a number of causes to this, including unsustainable fishing, and agricultural practices, logging, and climate change. Next slide. So in response to the global decline, nearly 200 nations signed what's called the Kunming-Montreal Global Biodiversity Framework in 2022. And it's a commitment to halt and reverse nature loss. As a result of this framework, the Nature Positive initiative was launched by 27 of the world's largest nature organizations, including the Nature Conservancy. And this graphic shows the current downward trajectory for global biodiversity and the global goal of getting to full recovery by 2050. Next slide. So you will likely hear from this point on in your lives, and maybe even today, the terms nature positive used interchangeably with a term called net positive impact on biodiversity. But it's important to know that these are two different concepts and that they can only be implemented in different delivery mechanisms. So nature positive, as we've discussed, is a global goal, which requires global effort and global enabling conditions. An individual project can produce a net positive impact on biodiversity at a project level, and that net positive impact can contribute to the global nature positive goals. But an individual offshore wind project or other development project cannot be nature positive on its own. So achieving project level net positive outcomes require the sequential application of what is known as the mitigation hierarchy, and net positive can only become a focus at that project level once no net loss for a priority species or habitat has been achieved. So let's just take a quick look at the mitigation hierarchy. The next slide. So as I said, before we can even begin to talk about moving a species or habitat from a declining status to an improving status, we have to get to a baseline of zero loss for that species or habitat that we're focusing on. In the mitigation hierarchy, getting to zero is often referred to as no net loss, and that's measured by how well we avoid, minimize, and mitigate the net impact to a species or habitat over time. On this slide, the no net loss is represented by that white horizontal line at the top of the slide. So keep in mind that even if we required every development project at an individual project level to get to no net loss, that accomplishment alone is not going to be enough to reverse or even halt biodiversity loss, the global biodiversity loss that we're seeing on the previous slide. So that's giving you some sense of policy incentive right there. The mitigation hierarchy refers to this well-established scientific approach to achieve no net loss. Step 1, where possible, avoid impacts. That's the step represented on this slide by that shorter red bar to the right of total impact. Step 2 is minimize impact. So you're selecting actions to reduce the scale or the duration of impact. And then step 3 is mitigate. You're trying to mitigate those additional residual impacts. And this could be paying money. It could be through offsets, like eradicating a vector species for a nesting colony of impacted birds. But even after all of this, you're still only at that horizontal line of no net loss. You haven't gained anything for that species. And then one final point that has implications for policy in the United States, applying the mitigation hierarchy, unless we're talking about endangered species or listed species, is almost always voluntary. It's not required, and there are no requirements anywhere to go above no net loss for a species in US regulations. Next slide. So the Paris Climate Agreement and the biodiversity framework have been drivers of policy and finance levers that are bulleted on this slide. And there's just a couple that I'll point out and we can talk about in more detail later. But the EU Corporate Sustainability Reporting Directive requires companies to measure and prove, really for the first time, the success of their sustainability claims as part of their reporting obligations. So that really changed the dynamic for what companies had been doing to kind of a whole new system that they had to look at to not only choose priority species and habitat, but also demonstrate success. And then the biodiversity related bidding criteria in the North Sea, those are really been drivers for offshore wind companies to compete, not just on the lowest price for the electricity, but on how much ecological benefit they can deliver. And that becomes part of the competition to secure contracts. So because of these policy and finance contacts and regulations, offshore wind companies have been designing for biodiversity and restoration to win contracts in North Sea countries. But bear in mind that while there is this regulatory guidance and incentive in Europe, here in the US, the lever for biodiversity positive action has been inconsistently applied, required, guided, and is primarily driven by voluntary corporate goals related to how these global corporations secure financing. So in the US, offshore wind companies had been starting to ask regulators for more guidance about how to select priority species and habitats for their voluntary biodiversity positive goals. And the last slide, which I'm not going to really talk about right now, but we can bring back up during discussion, are really the enabling actions that TNC co-wrote with Ørsted as part of the UN Global Compact Ocean Stewardship Coalition to help guide developers in how they're thinking about achieving net positive impact at the project level. And there are a series, and I would like to talk about this later, there are a series of enabling actions that are also necessary for government and regulators, for research and academia, and for the finance sector. This is not just that we're asking the offshore wind industry to solve a biodiversity loss problem that has been created by a lot of other things. So I'll pause there for now and let the next speaker take over, and we can come back to some of these topics in discussion.
Well, thanks, Trish. And really, the policy environment in Europe is critical. I've been pushing this idea for over a decade in Europe, and it's really only gaining traction because of those changes Trish describes. But with that policy environment as a tailwind to help with our restoration, I'll give a quick description of some of the proof of concept work that's being done in Europe. And first is a description of how to restore an oyster reef. I mean, this is nearly comic strip level, but that's actually pretty accurate. And to restore an oyster reef is the reverse of overfishing an oyster reef. To overfish an oyster reef, dredgers went out, scraped the oysters off the outside of the reef and sold them. But then what was left was a valuable raw material for the lime kilns to burn to make lime for mortar. So those same dredge boats went back and ripped up the oyster reef and sold that to the lime kilns. And the lime that was created has built the cities. It doesn't matter where you're looking, really. Paris, Amsterdam, London, Beijing, Shanghai, Melbourne, Sydney. They're all being built from the 16th and 19th century on burnt oyster reef. So the reverse of that process is build a reef base and then add the oysters. And that image is rock that's been barged down the Mississippi to build a reef in Matagorda Bay in Texas. This is actually work that's being done on the third runway of the Hong Kong International Airport. They've expanded the international airport and we're turning the scour apron around the new third runway into oyster reef. And that is recycled concrete rubble that's being used there. This is limestone that's going into the reef base to make Windara Reef in South Australia. And you can tell from the equipment and the scale that this is not a cheap exercise. It's the most expensive part of the restoration work is in fact building that reef base before you get the opportunity to add the oysters to the outside. So if we have a look at the North Sea, all of the infrastructure that is associated with the offshore wind industry in the North Sea has scour protection around the bottom of it. Now, we've all seen a rock or a post or something that's been in the intertidal on a beach, and at low tide, it has a pool of water around the bottom of it, always. And that's because as water moves past something solid, as the tide comes in and out, the water creates an eddy, or there's an eddy created, and that eddy digs a little scour hole around the bottom of anything solid. If you're thinking about a pylon big enough to hold a 7 kilowatt turbine in a sea with as much energy as the North Sea, the engineers get worried that that scour hole could get big enough to actually topple a wind turbine. So to avoid that, around the base of all of the infrastructure that is associated with offshore wind in the North Sea, there is a scour protection layer, and that layer is rock. It's 1 meter deep and 30 meters wide around any infrastructure. The image on the left is a 4-pipe vessel adding rock to a cable crossing. Now, the power is cabled ashore from the offshore wind parks. The cables tend to be buried, but whenever they cross other infrastructure, they need to come to the surface, and those cable crossings need to be covered. All of the turbine bases need to be covered. It doesn't really matter what the shape of the infrastructure is. Around the base of it, there is this scour protection. And the industry, the offshore wind industry, calls that scour protection. I look at that and think that's oyster reef base. So the challenge for the restoration community in Europe is how to add the biology, add the oysters to that, so that as the offshore wind industry is building this massive amount of infrastructure, they are at the same time restoring oyster reef. And to describe that process, I need to step back a bit. Remote setting becomes an important technique, in my mind anyway. It's not new. It's been done. The first time I did it in the US was in 2004. So it's well practiced, but I was hearing from Europe that no, the Austria are a different genus. They don't respond the same way. You can't use remote setting. To which I said, have we tried? And went and actually undertook some of the demonstrations, firstly in South Australia, then in the US West Coast where the Austria is the native, and then England and the Netherlands with archery wilding, before expanding that out and converting the setting gear into 20-foot shipping containers, equipment that's familiar to the offshore industry, so that that's something that they can handle. We needed to test deployment methods, test the mortalities that are associated with those deployments, and then monitor that post-deployment performance. And we actually have just started a project in Europe to put all of this information together in a package, the topping project, for the offshore industry to use. And then the piece that is still to be done is to develop those success metrics and integrate this into the offshore wind industry. But I need to point out right up front that to do any of this work with the offshore wind industry means you've got to be time effective in order to be cost effective. These are expensive toys. These ships are purpose-built. All they do is deploy rock, but operating these costs between 600,000 and €1 million a day. So you can't cost ship time. You've got to integrate into an operation, or at least my working hypothesis is I've got to integrate this program into the business as usual for these ships. And that involves the remote setting. Remote setting is very simply the hatchery production of oyster larvae. The spawning and breeding and rearing of the larvae is a fairly specialized operation. That gets done in hatcheries, but to set those larvae on rock, the larvae are free swimming. When they're ready to set, I can actually strain them down, as in the top left there, and wash them through a very specialized piece of equipment. The center photo on the top there is actually a coffee filter. A neat little piece of equipment to collect up larvae that can then be cooled. And the cooler at the bottom there is as simple as it gets. It's all you need. By the time they're cooled down to 4 degrees, you can leave larvae in suspended animation essentially for up to 4 days. You can go anywhere in Europe in 4 days and then warm them up. The photo on the right there is actually 5 million oysters. And that's my thumb for scale. So those then get warmed up and put into a setting container that contains whatever substrate you would like to put them on. And the setting containers, as I've described, we're adapting 20-foot shipping containers. And the kind of modular arrangement that is being organized includes a container for water treatment, a container for algal production. We usually have a storage container and then a varying number of setting tanks built into these 20-foot shipping containers that can then go off on the rock deployment full pipe vessels. So this is what it looks like. The RESO project in the Netherlands. It was set up in the port of Rotterdam. You can see some of the container operation in the background there. Fairly low-tech shipping container design in the foreground. If we have a look inside, the picture on the right is a full height 20-foot shipping container. The one on the left is a half height, both lined with a rubberized EPDM liner, the kind of thing that goes into koi ponds. And that's a very straightforward way of converting quickly a shipping container into a large setting tank. The Reef Recovery project in Belgium has a slightly higher tech approach. The container on the left there is the setting container. The one on the right is the water treatment container. You can see a protein skimmer, biofilters, and a storage container there for water that's heated and run through these filters to condition the water before going back into the setting container. These are loaded with rock, where the containers of rock there are actually ones we used last year. We are currently building stainless containers that are full height, 4 containers per setting tank, designed to be lifted over the hopper of a full pipe on those large vessels, with a trapdoor at the bottom that can be tripped so the rock spills straight into the full pipe. Inside, we need to maintain aeration. That's both for oxygenating the water, but mainly to actually create the currents to get the larvae evenly distributed within that tank, so that you don't get a whole stack of larvae setting on the outside or the top of any of those rocks, but they are setting evenly throughout that tank, and we've demonstrated that process. So to have a look at the mortalities, the different deployment styles, and some of the mortalities associated with that. This is surface deployment, so simulating a crane lifting one of those containers, holding it at deck level above the water and just dropping rock over a scour protection field. This was done at NEOS, the Royal Dutch Research Institute, that has a seawall at high tide, which was convenient. We could drop those stones, wait for the tide to go out, pick them up and check the damage. And those brown circles are highlighting some of the mortalities that were associated. But that was under 30%. That was about 28% mortality from surface deployment. It's a little difficult to test the mortality from the fall pipe from one of those large vessels. It's hard to stick a bucket under a fall pipe in 30 meters of water in the North Sea. So we built a simulation to do that. Put rocks with a known number of larvae along with a whole stack of other rocks as company, and toss them down a simulated fall pipe. That experiment was repeated, and I was actually quite impressed that the mortality associated with that kind of rough treatment was only about 45%. So that gives us confidence that if we double the number of larvae of spat that we hope to see settle on the bottom, then we are accounting for that deployment mortality. So this diagram is actually a diagram of one of the ships pictured at the bottom right there that will be used to deploy the reef covery project oysters to the Princess Elizabeth Energy Island in Belgium in about a month's time. You can see there's plenty of shipping container storage facility on board. They can take, pretty much any number of 20-foot shipping containers with rock containing oysters on any given trip. So we'll be testing that very shortly by deploying to the Elizabeth Energy Island, which is an interesting one. This is essentially an island that's being built to serve as the substation for the Belgian section of the North Sea and the power produced. So the power produced will be cabled into that substation island before coming ashore to supply the Belgian grid. And this is a rendering of the Elizabeth Energy Island. There's a diagram of the energy island in the top right there. We will be deploying to the southeast side, and we'll actually be deploying on the middle section of scour protection that you can see depicted in that diagram. The other place that we are deploying is on cable crossings. The Dutch project, the RISO project, will be deploying this year to 2 cable crossings. These are operated by Tenet, the grid operator, supplying power to the Netherlands and southern Germany. And you can see that these cable crossings are pretty sizable. It's 120 meters long by about 80 meters wide. It covers just over 2 acres of area. This year we'll be deploying oysters to 2 of those cable crossings. The plan for next year is 16. So this is scaling up pretty rapidly. But the intention here, the picture in my mind that it's a large consortium of people that have bought into this idea in Europe. The picture that we're planning to develop is where these ships are loading rock. We can set up these mobile remote setting containers. So picture you kind of 18, 25, 20-foot shipping containers lined up here, algal production, water treatment. We have access to water and setting spat on rock so that whenever a ship is loaded with rock and ready to sail, they can grab as many containers as is appropriate for the area that they're deploying, so that the last layer of rock that goes out has oysters attached. And this is a picture. Not all of the loading facilities are in Norway, but a number of them are. Convenient area there with deep water fjords with quarries adjacent. So you can see here there's a rock face to the right. The rock is going through a crushing rock crusher, being stockpiled and conveyed directly into the ship. So that's where we would be putting containers within crane reach of that ship for rapid deployment, or at least that's the idea. So that's a quick look at where I see the oyster restoration going in conjunction with offshore wind in Europe. And I point out that this is the first mesophotic marine restoration that's being undertaken. At the beginning, I described the critical coastal ecosystems, and they are really important. I mean, the coastal bays and estuaries are the most productive areas of the entire ocean, so I do not want to take any focus away from our coastal work. Those habitats are absolutely critical. But the mesophotic area is huge, and there's a fairly unique set of circumstances that leads me to the North Sea region and oyster reef in the North Sea. But a lot of mesophotic, think continental shelf area, should be occupied by sponge habitat as the biogenic structuring habitat. And to describe that, I'll hand over to Dr. Chris Gillies from Australia to describe work he's got going on there.
Hello everyone, thank you so much for inviting me along today. Apologies I can't be there in person, but I trust you're having a fantastic time with Boze, Chris and the team. My name's Chris Gillies, I'm the Managing Director of Offshore Biotechnologies. We are a company based in Australia working in the nature positive space. We're involved in coastal protection, environmental economic accounting, habitat enhancement, marine offsets and fisheries management. And we work throughout the whole value chain, so from strategy through to execution and reporting. We're working at the moment a lot with government, in particular around marine protected areas and offshore energy, subject of today's topic. Now, I know we're talking a lot about wind, but the decommissioning of oil and gas infrastructure is really important too, and there's a lot of traction in Asia Pacific around that at the moment. Ports and harbours that obviously support all of that offshore energy work, deep sea mining as that comes along, and of course telecommunications. So wind, yes, massive. Yes, it's massive, but so is oil and gas, deep sea mining, and many other groups really operating in the blue economy. Now, Boze has spoken to you a lot about oysters, I'm sure, but today I'm here to talk to you about sponges, and it's a battle between the filter feeders, I think. And in particular, I want to talk to you about the Seabed Restoration and Enhancement Project. So it's a 3-year project that is part of a collaboration with government, the Australian government, recreational and commercial fishers, the offshore energy sector, and ourselves as being project managers, and we actually conceived of the project as well. What are we working on? Well, we're working on the restoration and enhancement of mesophotic sponge communities, and you're staring at one at the moment. Our site was in the southern part of Australia in a place called the Apollo Marine Park, and we were working 12 miles offshore in about 80 metres of water. Now, in Australia, no one's ever done a project like this. No one's ever tried to restore or enhance deep water sponge communities. In fact, they've never tried to restore shallow water sponge communities. And it's probably nice to know that somewhere in the world we haven't dredged all of our seafloor to capture fish or put in the infrastructure. No doubt, where you are, parts of the seafloor perhaps would have looked like this and hopefully still look like this. Really abundant, beautiful communities on the seafloor. Now, this project had 3 key questions that we were trying to address. The first one is, can we reseed sponge communities? Not only can we do that from a biological sense, but what does it look like when it comes to logistics? How do you transport sponges? How long do they live out of the water if you were to sort of deploy them from the back of the boat? What does all of that sort of background stuff look like, as well as the frontline ecology? We also wanted to know, well, can we facilitate recruitment? Like you would have heard about the need for substrate and oysters and deploying the two. Well, it's the same thing. Sponges typically require a hard surface to settle on. So what does that look like in terms of, the availability of those surfaces, the texture, the chemical composition, the shape, etc.? And lastly, can we do all of this cheaply? It's one thing to do it in a research environment where we can kind of spend lots of money on research materials, but how do we do it cost effectively where we're really getting down to the cost of cents per unit or fraction of a cents per unit? And that's thinking about natural materials, commercial deployment methods, being able to do this over square kilometres, not over square metres. Why sponges? Well, if you don't know, sponges are amazing, but they are really the number one habitat former once we get out of that photic zone. So once the primary productivity from sort of macroalgae and kelps, etc., drops out, it's sponges that take over. They are the filter feeders, they are the pumps of the world, and they are really biodiverse as well. So well over 30,000 species have been described, and there's probably that many again that are left undescribed. So most of our commercial fisheries, our benthic commercial fisheries, are derived in these mesophotic ecosystems as well. And we're just starting to scratch the surface on some of the biomedical potential that sponges have. And a quick trivia one for you. The first leukemia treatment was derived from a marine sponge in the Caribbean. We now have many other types of medicines and marine products being derived from sponges, but they are powerhouses when it comes to bioactive compounds as well. So really important fisheries, health, and of course, productivity of our oceans. Now, in order to restore these ecosystems, we need to think along the same lines as what's just been described around shellfish. We first need to think about the abiotic component of the ecosystem. What is the underlying substrate that these filter feeders are inhabiting? And there are really two types in the Apollo Marine Park. The first one was around exposed bedrock. We have bits of bedrock, particularly in the shallow waters around sort of 60 metres and above, but certainly in deeper areas, we still have these exposed reefs. So we selected concrete reef mats that are already in use in the commercial sector as scour protection or to protect cable or pipeline crossings. And we modified these mats to make sure the chemistry was right, the rugosity was right, and looking at sort of microtopography as well. The second one, a second substrate we wanted to look at were these boulders. And then all over the ocean, most again, filter feeders have a larval life stage. They're looking for a clean surface to settle on. And it's these boulders that were placed, or rubble that was placed many millions of years ago, or maybe it's a shell fragment from a scallop or something that they land on. And we wanted to look at what are the trade-offs around sort of a low density, spreading it over a large area versus a high density level of limestone that might aggregate more biodiversity, but perhaps be more costly. So these were the two primary sort of abiotic factors that we're looking at, and we're trying to mimic the environment and mimic what they would naturally be settling on in the deep sea. Now, in order to be able to repopulate the oceans, you've got to have seed. So let's think about the biotic component of the ecosystem. We didn't know anything about the sponge community. There's really only a couple of published papers in Australia, so we went to a rapid prototyping methodology. We worked with our partners at Amplitude Energy to get some sponges from these Christmas tree manifolds, 150 metres deep out there in the Southern Ocean. They were able to scrape a little bit of sponge off the side of these things. They flew them in their private helicopter to an airport near the hatchery where our sister company, CGN Aquaculture, was successfully able to fragment them and begin to reproduce these sponges. Now, it was only a couple of individuals, but it gave us really good proof of concept that we could at least pull things up from the deep, cultivate them in a hatchery, and then we were hoping to be able to replicate the last or do the last step, which is actually deploy them back down there and watch them grow. So we did that. We went out to Apollo Bay. We steamed 12 miles offshore. We worked with some commercial fishermen. We collected some sponge fragments. You can watch the video on our website, us doing that. And we collected over 100 different species of sponges. Now, we're on a tight timeline. We hadn't done the genetics. We didn't know the different characteristics of the sponges. We just went, let's get in there and give it a go and see what comes out of it. In fact, we learned a lot by doing it that way. So out of those 100 different species, we had 800 clone fragments and just about all of them survived. Not only did they survive, but the parents survived as well. Across lots of different functional groups, we were able to demonstrate survival over 3 months in the hatchery. So we know that asexual fragmentation of sponges, the same method that we use for corals, works really well for many of these deep water species, at least in our neck of the woods. Now, we wanted to put those sponge fragments directly on the concrete mats. We weren't able to do that. The pH wasn't quite right. We hadn't had them weathered enough. So we created these little, what we call sponge donuts. The pH wasn't quite right on those. So we ultimately had to put them on some ceramic tiles and then put those onto our mats. Now, why do we put them onto the mats? Well, we're a long way off the ocean, and AUVs are good, but not that good in terms of being able to find a rock right out there in the middle of nowhere, but we can certainly find the mats. So we stuck them on the mats to make sure that we could find some of these sponges. So we took all of that knowledge and we steamed out of the heads here at Port Phillip Bay out of Melbourne with 64 of these reef mats on board, 130 tonnes of limestone rubble, 8 cubic metres of recycled shell, and over 400 of these donuts with sponges attached. We learn a lot logistically about how to do this, how to work at sea, what works, what doesn't work. Having an excavator float around the Southern Ocean was really interesting, but they did a fantastic job at deploying the substrate at different densities on the sea floor. Now, results, well, at the moment, we literally have AUVs out there today. We've got a big, long week of fine weather, and so I can't show you too much, and I'm going to leave you in some anticipation there around exactly what's come out of it the last 12 months, but I'll give you a little snippet. So the first thing that we're doing is that we are doing some fantastic structured from motion processing with our AUV footage, where we can be able to calculate biomass growth on these structures from videos. So repeated assessments give us a biomass estimates. We have a PhD student working on that at the moment. Of course, we're doing fish assemblages, tracking beta remote underwater videos and other video analysis to look at how fish assemblages will track over time. The epibenthic communities, the sponge communities, of course, is what we're interested in. And really excitingly, we're actually doing this over a 30-year period. Now, at first, when we had to get a permit to do this out in the ocean, it was a sea dumping permit, and as part of that process, you have to monitor for 30 years. It freaked our partners out at government, Parks Australia, to say, how are we going to fund this? But it actually is a negative into a positive, because we now have a funded 30-year monitoring program where we can begin to look at the ecological succession on these materials and actually track how these ecosystems form over time. And that's something we've never been able to do before, because whenever we put infrastructure out there, be it oil and gas or a pipeline, it's always retrospectively the biologists come along and go, wonder what might be growing on these things and what does it look like in hindsight. Whereas it's the first time in Australia we're actually putting something out there and getting on the front foot when it comes to looking at the ecological patterns and succession of this substrate. Where to next? Well, this was a fantastic prototype. Again, I wouldn't say it's a full-blown project, although it's pretty exciting in terms of the scale that we got to. We're now looking at really starting to automate some of these processes. So being able to collect the sponge fragments in real time, cultivate them using some ship-based methodologies and some sort of rapid cultivating methods, cutting methods, seeding them and deploying them all within a 24-hour period, all on site. So we can work in with the construction teams. They might put some scour protection in, and we can come in before they do that, harvest, cultivate, and then once they lay that scour protection, immediately reseed those areas. We want to get to the point where we can do at least a hectare, if not more a day, and we think that's really achievable. And we're pretty close to getting a project over the line here where we can begin to test these methods in a commercial sense. Now, what I'm really excited about is really leveraging all of your networks, all of your brains, and all of your enthusiasm for this type of work. So we not only want to do it down here in Australia, but we would love to partner with groups all around the world to be able to test and develop these methodologies in the deep sea. You've heard that, there's really a mountain of infrastructure that is going in and a mountain of infrastructure that's coming out. And we need to find ways in order to be able to restore and enhance and protect these critical ecosystems, be it shellfish reefs, seagrasses, or sponge gardens. We need to get onto these methods pretty quickly. So if you want to know anything more, please watch our videos. You can read a little bit about us in the news as well. Jump online to our website, Offshore Biotech, or give me a call, send me an email, get me on LinkedIn, whichever way to come and find me. I'm not buried under a rock. We'd love to talk about perhaps setting up some partnerships. Enjoy the rest of the lecture. No doubt Boze has got a lot more for you in store.
Yep. Okay. So I actually got an email from Chris this morning. So Friday, last night at local time, Friday in Australia, he got some of the results from that work that he was mentioning, and apparently there is good survival, and he's pretty excited about the survival that he's getting at the 12-month mark. So that's not necessarily a peep over the horizon into the mesophotic work. This is work that's actually being done. The oyster restoration in the North Sea is well advanced, and there is the experimental beginnings of restoration in what is the bulk of the habitat, or the sponge-based habitat on the continental shelf area. So with that, Marta, I'm happy to answer questions. Probably over to you.
Thank you so much for this fantastic overview. Super interesting to learn about the massive amount of learning that we have to do, that you had to do logistically from an economic standpoint. Very, very interesting. I think we should open up for questions. I would like to, while our audience starts thinking about questions, feel free to post them in the chat, or you can raise your hand, and we are happy to give you a space to ask questions. I'm happy to start with a question, unless perhaps I actually see we have Eleni here, and I think she might want to say a few words. Eleni Christophe is a professor of engineering in the Civil and Environmental Engineering Department at UMass Amherst. Eleni,
Yeah,
hello.
Hi, and thank you for the great presentation. It's always to learn more about, our oceans. And I'm a transportation engineer. I don't know much other than being originally from an island and love the ocean more generally, and all it comes with it. I've been with UMass for about 14 years now. I'm also the associate director of the UMass Transportation Center. So we do a lot of work on improving transportation and bringing sustainable transportation solutions. So I was wondering, as you were all presenting, the role transportation plays in your work, both on the upstream side, in the sense that, like, is transportation and freight transportation causing some of these issues you see with the oysters, and also on the solution side, how do you incorporate that in the decision making when you're developing the solutions for restoration? Thank you.
I guess I could start with answering that. The transport is an interesting one. I mean, the remote setting of oysters is all about minimizing the transport. So rather than setting larvae on the bulky, heavy substrate at the hatchery and having to move massive amounts of material, you get in before it becomes big and bulky and transport that little package of 5 million oysters that is very easy to transport. And really the excitement that I'm feeling about the North Sea is, given that the logistics are so completely solved for us. We have an industry that is massive, that is focused entirely on building what they call scour protection, what I call reef base. So they're doing it. They're dealing with all of those logistics and transport. And I mean, it would be a completely daunting thing for me to be trying to consider if that wasn't something that a massive industry had already solved for us. So in large part, I think that's probably done. The translation of that into other parts of the world will inevitably have some of those transport issues associated with them. I should say a couple of things about scale, I guess. One of the things that really excites me about the North Sea work is that I can't possibly picture trying to restore a system of that size without a partner with that kind of industrial muscle. I mean, you've got to match the restoration effort to the scale of the system that you're restoring. And the North Sea is big. So to effect restoration at that scale, you've got to go big. And you can't do that without a partner that has that kind of industrial muscle. So thinking about translating that into the other habitat types that are important, we need to be thinking about, what the connections there might be that allow that kind of scale for restoration. And I'm sure the transport issue is something that will be front and center there.
I would say too that obviously the regulatory landscape matters. And, in the United States, we have the Jones Act. It's caused a lot of challenges for the offshore wind industry. So that's the federal law that requires, that goods or services shipped between U.S. ports be transported on ships that are built, owned, and operated by U.S. citizens or permanent residents. And so, if you only have 3 wind turbine installation vessels in the world and none of them are built in the United States, then you have to, figure out how you're getting your waivers, and there's a queue and you're getting in line to be able to do those kinds of things. And so I think the types of ships that we're using and trying to align not just on the science, but trying to understand what the regulatory landscape is and what some of those limitations and obstacles are is really important to creating a smooth path for the delivery of these types of projects.
Great, thank you both, and thanks for doing this work.
One
Yes,
other quick
thank
thing that I might just add is that, the transportation impacts on the deep ocean are a lot different than the transportation impacts on the coastal environment. And so, Boze started off his presentation talking about those critical coastal habitats of eelgrass and salt marsh and oysters. And certainly when you're in the inshore environment, the impact of roads and trains that are constraining tidal flow, up and down the coast are a substantial challenge. And I think that there are a lot of folks, both engineers and conservation teams, who are working on finding the ways of, increasing the size of tidal culverts to restore natural flow to help keep, keep those coastal ecosystems going. So that's like a place where there's a lot of work going on, and we see a lot of value and are putting some energy into that space.
Yes, perhaps I was really thinking if we zoom out, and what do you think are the primary enabling factors, priorities that you think should be addressed to support, enhance this type of projects internationally, but also specifically in the US?
Specifically for the US, I'll hand over to Trish, and it's going to be a logical transition because I'll just tell a quick story of Europe, because my answer to your question is policy.
Mm.
It's all about the policy framework. 2017, I did a speaking tour of Netherlands and southern Germany, essentially saying the working life of a wind park is about 20 years. The permit that you have to operate that wind park says that at the end of the working life, you've got to take out all the material that's been put in. Cutting off a pylon big enough to hold a 7 kilowatt turbine and getting that out of the water is a big exercise, but it is cheap compared to dredging out all that rock. Why don't you help me turn that into an OSPAR protected habitat, and you won't be allowed to take it out? I will save you millions, if not billions of dollars. And everybody said, wow, that's a good idea. And then nothing, no follow-up. It was not until the non-price criteria policy was established in Europe, whereby the points awarded that determine whether you win a tender or not, up to 30% of those points typically went towards this net positive impact description in the tender. And that's when people suddenly said, hey, where's that bloke that was talking about oysters? We need to have a chat to him. So Trish, how does that translate to the US situation?
Well, it doesn't really translate, which I think is part of the problem, although it's starting, we had been starting to see states kind of pick up this non-price criteria coming into 2020, 2024, 2025. But so just to step back, the non-price criteria, that the general concept there is that ordinarily when you're competing on a contract to buy energy, the competition is about who can deliver an X amount of energy at the lowest price. The countries around the North Sea, in part due to directives coming out of the EU and the UK, and in part in response to the biodiversity framework, started rewarding bids that were addressing biodiversity. So it wasn't just a competition on price alone, it was also a competition on the value of the ecological benefit that you were delivering. That does not translate necessarily or easily to the model that we have in the United States. So if you just take, like, I'll use Rhode Island because I'm most familiar with that. You have a ratepayer advocate. Their job is to protect the ratepayer, which is a different class than the taxpayer. So ordinarily, you would say these social benefits, investments in nature, investments in the workforce, community benefits agreements, helping us develop supply chain, helping us expand and improve our ports, are expenses to be borne by the taxpayer, not by the ratepayer. What happens in the United States is that all of those costs, those social non-price costs, get built into the bids that we've forced offshore wind companies to design around. And if they're not getting enough return on investment for adding, we're going to commit to marine restoration, or we're going to commit to this much in community benefits or fisheries compensation, then you're actually putting them, the better projects, at an economic disadvantage to the projects that are just delivering on the lowest possible price. And we see all along the coast, states have different models and different approaches for the way they buy energy. And some of them put more of a weight on some of these non-price factors than other states. So that's a huge challenge just in and of itself, the way that we buy energy and the way that we incentivize kind of these non-price or non-cash aspects. And then there's just like I think the compartmentalization of the way we, on the science side, of the way that we collect data about the ocean. So in order to do the things that Boze is talking about really successfully, we have to have good, consistent, transparent baseline data about the conditions in the marine environment before we start. And then we have to be able to access monitoring data transparently and have that be readily available and easily shared across the industry so that we can start informing the best practices. And we don't really have a great system for that in the United States. It is very compartmentalized. We don't really pay to store the data we collect. Some of the data collected is proprietary because a particular company has developed a very unique way to gather that data, and it varies very much between lease area and lease area. And so that can really undermine the ability to demonstrate success, which is obviously part of the narrative and convincing states that it should be part of the model when you're buying energy in the first place. So it's kind of like this big cyclical, challenging problem. But I will end that on a positive note, that we did see a number of states really start to build into their state's terms and requirements for projects, that we're going to be commencing in 2028, 2030 to address some of these non-price things. And we weren't doing it as smoothly as we've seen in Europe or consistently across states, but it definitely has been part of the conversation.
Thank you, Tricia. Any additional questions? I have a few of my own as well, but I wanted to check with our audience. It seems to me, based on our discussion so far, that especially in relation to what Tricia was referring to in terms of monitoring and data collection, perhaps cross collaborations could be beneficial. I was actually wondering also in terms of, initially I was thinking about inter-regional collaborations. I'm sure that there is some sort of capacity transfer between Europe, the Australian case studies, and the US. I was also wondering if cross-sectoral collaborations, including academia, could be beneficial for monitoring and evaluation. In my own work, assessing the cost effectiveness of nature-based solutions, I realized how important monitoring is, how challenging it is. Chris was mentioning the challenge in Australia that sometimes monitoring is like ex post. Let's check what happened in that area after things have already been developed. And I was so impressed when the 30 years monitoring was included in the slide. That was like, wow, mind blowing. So I was really wondering, what do you see as potentially beneficial for your work, for this type of projects, in terms of cross-sectoral collaborations in an ideal world?
If I could perhaps start on that one, Marta, that's such an important question. This marine habitat restoration is too big to have any one organization try and be a king, or to have any one person try and be a king. It has got to be collaborative. Egos only get in the way when you need multiple groups working together to get something done. And the marine habitat restoration falls squarely into that category. It's just too big for any one organization to take on. It requires collaboration in whatever we're doing. And that includes the nearshore, the coastal habitats that we've started off describing. So there is any amount of potential for that kind of collaboration. There's more than potential, there's a need for collaboration. So the details of that obviously relate to the details of a project and what the priorities are for translating some of this work to the geography in question. And I'm thinking the Northeast here. But certainly collaboration is absolutely critical. I don't know if others have comment on that.
I know, if you're not familiar with it, the Regional Wildlife Science Collaborative was established kind of in response to the offshore wind, or directly in response to offshore wind projects, being a number of them being proposed. I think at one point we had close to 55 gigawatts of projects kind of in the pipeline, which is significantly reduced now to like less than 10. But Regional Wildlife Science Collaborative is like a multi-sector organization. So there are different caucuses. There's an offshore wind caucus, environmental nonprofit, federal and state government, and then academic and research institutions. And they've worked together to design an eco-regional science plan, an integrated science plan that identifies research needs, data needs, opportunities along the Atlantic coast, both in response to concerns that have been raised about potential interactions with offshore infrastructure, and also in response to needs that have been identified by the offshore wind industry. And so they kind of work together in that way and are really starting to build up that I would say eco-regional collaboration around science needs, which is really important. There are a number of organizations and collaboratives kind of around the world that are trying to do similar things, and I think in Europe as well. It's really, for me, when I look at it, it really does come down to the data and like how you're able to access data, how timely that access is when it becomes available, and then how it can be used by those different sectors to kind of feed into these different processes that are underway. So I think those are going to be really important, those types of data management systems and collaboratives around data as we go forward.
And just to pick up one other thing that you mentioned, Marta, about collaborations with universities. In many cases, the wind developers in the US have contracted with universities to lead monitoring efforts. So UMass Dartmouth is doing a number of projects. University of Rhode Island, Rutgers, University of Maryland, a lot of these schools that have big ocean science programs have been really involved and contracted directly by developers to do this before and after, before, during, and after monitoring. So there's actually been an incredible increase in the amount of projects, monitoring projects happening in the deep ocean because of the wind industry. I think they're something like 70 projects have been started in the last couple of years, in addition to the standard monitoring projects, but ones that have been funded through various funding around this. So it's actually a sort of a golden era for monitoring in the U.S., and we're trying to really identify the ways, while the wind industry is sort of struggling right now, what are the ways of keeping the science side moving and answering the questions that we're most interested in to help with habitat restoration and fisheries and all sorts of other things.
Thank you so much. Any questions from the audience or contributions? Please, Rob.
Yeah, this conversation made me wonder, and I guess this is for Trisha, Chris, and Boze. Is there a place for citizen science in observations in long-term monitoring? Not so much, of course, at the footing of an offshore wind turbine, but maybe in a more near coastal interventions.
I mean, I can,
Yeah.
certainly the, access to the areas that are 20 miles offshore and in 50 meters of water is a hard place for citizen science. There are some efforts going on with recreational and commercial fishermen that are sort of like citizen science. But I think the place where these projects come to shore is with the extension cord, where the projects have to plug into the shore to deliver power. And there are probably some opportunities. I don't actually know of any real citizen science projects that are happening right now, but I think that there certainly are opportunities where the cables do come ashore to think about that. It's a great idea.
Yeah, it's important. It's a difficult place to coordinate citizen science as an organization because nobody wants to take on liability for that. But there's some good examples around. There's the scuba clubs, the dive clubs in the UK are very plugged into monitoring and recording oyster habitat around the UK. And as an independent entity, you get around some of those liability issues, and they're providing great data, fantastic information. So there are certainly ways of doing this, and it's worth thinking about.
We have a couple of questions in the chat. Alison Bowden, hello Alison, asked, would the oyster restoration you described for Europe work in the US? And Tova Salcedo added to this, so adding on to Alison's question, I noticed that South America and Africa were lacking data points. Is that due to policy or is there anything ecological at play? Thank you in advance for your answers.
Okay, so to take the first one first, the genus of oyster in Southern Australia and Europe is different to our eastern oyster. We have a Crassostria. The oyster in Europe is an Ostria, Ostria edulis in Europe, Ostria angazi in Southern Australia. And the Ostria are full salinity species, so they can occupy those oceanic areas that are in deeper water and full salinity. The Crassostria we have here is an estuarine genus. And they really do need that freshwater input, the estuarine environment, for recruitment. You can grow an eastern oyster just about anywhere. They're not going to recruit anywhere, and you need recruitment to keep a reef going. So unfortunately, is a fairly unique set of synergies in Europe that lead me to be focusing there on oysters. I really think, as Chris was mentioning, where power is coming ashore, where the infrastructure, the offshore infrastructure connects to our shore-based grids, there is plenty of potential for some of the oyster work. But it's one of the reasons for thinking a little bit about what are the other habitats in the northeast, and sponges in deeper water and the mesophotic come immediately to mind, which is why I thought the sponge work that Chris Gillies has started in Australia might be of interest, because that does translate directly. And to answer the second question, I have been a little frustrated about Africa and South America for a couple of decades. So, Tova, I'm with you on that one. I actually have been speaking to a number of different countries in South America recently, and there is plenty of potential and plenty of need for focusing on the habitats that shellfish provide, and the marine habitat restoration more generally in both of those areas. I think we have the kind of conditions that will see that progress in South America. I'm looking at the Angola Namibia coast at the moment as an area in Africa, but there's a lot of space in Africa that is underserved in terms of trying to put back these productive habitats to support, fisheries and populations.
Thank you so much. Any other questions from the audience? Maybe I would actually like, as we reach almost the end of our session together, I was wondering if you would like to share some final thoughts, if you had a message, a final message for our audience, some final considerations, maybe some optimistic thoughts, anything you would like to share with our friends online.
I certainly do. So I once again, I hope I'm not hogging the limelight here, but others can hop in after. Um, it has struck me over the decades that people's mental picture of the bottom of the ocean, the sea floor, is that it is in reasonably good condition. And unfortunately, it is actually in any of the areas where we have these measures in worse condition than the terrestrial biome. We have better habitat integrity in the terrestrial area than we do in the marine. So there is enormous incentive for putting some of that habitat back. The optimistic part of that is that we are in such a different place now than we were even 10 years ago in our ability to put that habitat back. The projects that have been undertaken, the practice we've had, the mistakes that have been made, the learning that's been done puts us in just such a much better position now than even in the recent past. So we are well positioned to actually make a difference in restoring some of these marine habitats. And a relatively small footprint of marine habitat influences a pretty large area of ocean because of that productivity and the influence that it has. So yeah, in a lot of the situations that we're talking about, we can do this. We have enough. We know enough. We can get going. There's always more to learn, but there's no need to stop progress to learn before we start.
Thank you, Boze. Maybe Trisha and Chris.
Sure. I mean, I'll just say I've listened to Boze's presentation a few times and know about his work. And every time I listen to him talk about this work, I feel energized and optimistic. And I know without even seeing faces on the screen, I know you feel the same way. And I think it's really important to ask yourself, why is it that you feel that way when you listen to this? And it's because for me, it's because it tells us that we can do more than one thing. We can respond to the climate challenge. We can build clean energy. We can address biodiversity loss. I used to say kill two birds with one stone, but now I say save two oysters with one stone. We can optimize our approaches in these spaces and find the synergies and bring together these multi-sectors to achieve big things. And I am thrilled every day when I think about the fact that offshore wind is making these kinds of conversations and this kind of work possible.
Yes, that's really wonderful. I support this message. Chris?
Yeah, just the last thing to pile on to that, I'll say is, when Trish showed the figure about nature positive, the animals that you see in there are like elephants and whales and stuff. But the reality is that it's the little things that really make a difference. And trying to create the coastal habitats where the juvenile fish are raised, that's the bottom of the productivity, story, and it's super important. We've started to say, like no reefs, no fish, no salt marsh, no fish. We're, as Boze said, a lot of our coastal ecosystems are in pretty bad shape, and we've seen some incredible successes when we restore them. And so, like Boze said, we can do this, but it takes a lot of will, and it takes some demand from all of us. We need to be saying in our towns and to state agencies like this kind of biodiversity is really important to us, and we think that there's a way of leaning in to make the world a better place. So I'd love to hear Boze talk about this, and I also walk away feeling optimistic. Thanks to all of you for joining us.
Thank you very much with these very positive messages at the end of our lecture today. We are at the end. Before saying goodbye, I want to remind everybody that we will have a recording of this lecture. We will share resources. Boze and colleagues share with us numerous references, articles, and other resources. We will share all of it via email with participants, and we will also post it online. I would really like to thank our wonderful speakers, Boze, Trisha, and Chris, for being here with us, and the Nature Conservancy for collaborating with us on the organization of this lecture. I couldn't be happier with everything we have learned today. It was really exciting. Thank you so much also to our audience for being here with us for a little bit of a longer lecture today, and so rich. Thank you so much, everybody.
Thank you.
Thank you.
Oh, and thank you also to all our partners who supported the Sustainable Solution lectures, of course. Bye-bye,
Yeah, thanks to
everybody.
you, Marta, for helping make this happen, and Marina and others for all the details.
Bye-bye.